Hi everyone, welcome to my channel. Today I will explain about ASIC Design Flow in very detailed and simple way. After explaining my design flow at last, you can check the notes I will present on the screen. Check at the ending of the video. Let us start the ASIC Design Flow. Hi everyone, I will explain about ASIC Design Flow in very simple. First of all, I will explain about specifications. In this specification, that which is expecting that information from the customers that is collected by the some marketing people. So example, so I need like I need a processor like Snapdragon, like camera with high megapixels, so battery performance and more. And next step goes to architect design. Let us in this design, it is based on a specifications. Like we are like take an example. I'm taking assume it is a phone. I want to design like I want camera at this place and yeah, based on the customer requirement, they have showed processor like Snapdragon, camera, pixel, processor, memory. So we need to exactly design at the same as the customer said in architecture design. Next step goes to the RTL design. RTL register transfer level. It is a digital design using combinational sequential circuits in HDL like Verilog. This above architecture is converted into Verilog code. This code describes how the data is transferred and is passed from registers to registers. And next step, RTL verification. In this verification, when we write the RTL design, we apply test benches. So that used to verify the design in verification stage. If in this stage, if any mistake is found, the design is resent to the RTL team. And the next step, synthesis. And the actual PD design flow starts here. It is a process of converting the RTL code into gate level netlist. And this RTL verification, the design is technology independent. Is in this synthesis process, the design is converted into technology dependent gate level netlist, like a .v file. And the next step, DFT, design for testability, is a technique used to facilitate the design to become a testable after production. In this state, we put an extra logic like scan path insertion along with the design logic during implementation, which helps to post-production process. This DFT will make the testing easy at post-production process. And the next step is floor planning. The floor planning is the process of determining the die area, and it determines the size of the die area and creates wire tracks of the placements of standard cells. It creates the power straps and ground power drum connections. In this state, we can place macro placements. And the next step, placement. Placement is a process of automatically assigning the correct position of a standard cell that should fix in a given area. In this standard cells, placementing the standard cells will place in the site rows, which is a legalized placement. After placement state, we check for congestion and timing. We'll also reduce it. In this series stage, we will build a clock tree by using inverters and buffers. To supply the clock signal from clock source, we build a clock tree. In this process, balancing the clock skew and minimizing the insertion delay in order to meet TP. TP means timing and power. Before going to the next stage, the connection between the macros, standard cells, clock, IO ports are logical connections. In this routing stage, we connect all the physical cells with metal straps. Routing is divided into two parts, global routing and detailed routing. In this global routing, in which the signals which metal layers is used. In detailed routing, the physical connections are done by us. Next step is sign off. After the routing is done in a physical layout, in this stage, all tests are done, like DRC, LVS, LEC, to check the quality and performance of a layout before tapeout. After this design is converted into GDSII file, that is a requirement in a PD file, in PD engineer. After this step, next fabrication. By using this file information, we need to fabricate a chip. Total design is converted into chip by manufacturing process in a foundry. Before using the chips in an IC, packaging and testing of in this the chips are made out of it. Then we need to test the chip before placing into an IC. Ensure it works properly or safely. Next chip, it is the final chip that can be used in other systems. Now I will explain based on the flow. In this, we know the RTL design verification is, wait a second, we know this too as circuit design. And the next, synthesis and DFT is a logical design. In DFT, scan-in and scan-out cells are present. And floorplanning is an power area. Next is placement. Placement is a placing of macros. So in other words, macros cannot be created by the software. It is placed by us in the chip. And the next is this placement CDS and routing is P and R. And this sign off, we have to do STA, which is the toughest stage in the PD. And these three are at the manufacturing stage. And thank you for watching this video. I hope you understand very well. I hope you understand this video. And in our PD, I am currently studying and focusing to become a PD engineer. So in this PD engineer, we need steps from synthesis to sign off. I will explain in very detail about this flow. Subscribe for more videos. Thank you.